Okay, hopefully I am live. I'm hoping I'm live. Everybody tell me if you hear me. Do you hear me and see me? Is there an echo? Hopefully not, but let me know. Looks like I'm live. Hello, everyone. Hope everybody sees me and hears me. I see Jerry. Thank you, Jerry, for being here. I see Mike. Thank you, Mike, for being here. Both of you are my Patreon. They're Patreon VIPs as well as the moderators for the chat, so please be nice to them. Good, no echo, good. And I'm loud. Remember, audio is always an issue with YouTube. Apparently, I'm not the only one who has issues with this. Excellent. Gareth can hear me in the UK. I'm screaming all the way across the pond. That's awesome. Excellent. Okay, fantastic. One person can't hear you, but a lot of other people can. So everybody's saying 5 by 9. Excellent. Thank you so much. Okay. Yeah, if you can't hear me, try rejoining. Maybe there's something wrong on your end because it looks like everybody else can see me. So see me and hear me. So thank you so much. Yes, we have a lot to talk about. Some very interesting things are going on, and that's why I decided to do a big live informal forecast. There's just too much going on too quickly that I just can't do a big forecast in time for all of this to be actionable, to allow you guys to make the decisions you need to make for whatever it is that you're doing. If you have questions in the chat, thank you so much, everyone. I see all of you just chatting away. This is awesome. If you have questions, please, and you put them in the chat and I don't see them, keep posting them. And then if after a while they don't get, I still don't see them because this chat scrolls by quickly, be nice to both Jerry and Mike, and maybe they can elevate your questions, because anytime I see them pop up in the chat, I pay attention, okay? And of course, for those of you who are on Patreon, if I don't get to your questions, put them in the Patreon post, and I will definitely get to them. I will check live, and then if I don't see them in time, then I will get to them afterwards. So you guys have extra access to me. So hello, everybody, and we are in for some fun. There's a lot going on in the sun, and yes, for those of you who are exhausted by getting all the alerts, so am I. Well, I don't get the alerts, but I'm exhausted by what the sun is doing. I can't even get forecasts out and get other stuff done because the sun keeps putting out things. We are very close to solar maximum. That's what that means. When we start having something close to 8 big solar storm launches a day, to the point where even NOAA and NASA have a hard time trying to model them or even find them, and we'll talk about why that's important in a minute, that you're close to solar max. So whatever anybody said, solar cycle 25 is going to peak in 2025, ain't going to happen. I'll bet you it's peaking, it's going to start peaking now. Now, perhaps if we have a double peak, it could easily extend into 2025. But I don't think it's going to start. I don't think the solar maximum phase of this solar cycle is going to start in 2025. It will be likely close to the beginning of this upcoming year, because we are getting really close. It's very, very easy to tell just by the way the sun looks and what's going on. Let's dive in. So I'm going to take a look at the sun right here. And I'll show you a bigger picture of the sun in a little bit that has sunspot numbers on it. So I'll make this very, very quickly because I'll jump to that very reasonably quickly. The big story, of course, was that filament that you just saw be launching off the Earth-facing disk. Believe it or not, that's not the only solar storm that's coming toward us. And one has been modeled, one has not. One snuck through the cracks. So I'll show you, that's the big filament right here. You'll watch it launch here in just a moment. Whoosh, right there. That was a beautiful filament. Part of it does look like it was slingshotted slightly to the west, which is good because that is what's allowing this thing to really make a beautiful halo in coronagraphs, and I'll talk about that more in a bit. We have a lot of activity. These are the new regions back here just on this side here. These are the regions that I was talking about. If you watched my last forecast and I was saying, ooh, we got some big players coming into view. These are they. And so we've got, let's see, what have we labeled this one? This one is region 3191 now? Yeah, so one of the big ones that we were talking about that we showed on the far side, 31, they've now labeled this one 3191. This is a repeat performer, I believe. And it just launched a big solar storm this way, along with one of the other regions down in here. There was a big eruption this way. So these regions are connected. Okay, so as they begin to rotate into the center disk, expect to look for a lot of activity that's kind of connecting these regions because there's a lot of synergy between them. So that's kind of what played last time they were on the Earth-facing disk. So it's going to be an interesting week ahead, not even talking about the activity that we're seeing now. Going to the east, or excuse me, going to the west limb, did you just see that? That big eruption, that was from region 3376 as it rotated to the sun's far side. That far side eruption is definitely not going to hit Earth, but that, when you see it, it happens just about the time this happens too. You'll watch this thing, and then I think this thing goes boom right there, and then that thing goes. That was I'm pretty sure that was the response, or the source of the radiation storm that we're in right now. We are in an S2 level radiation storm. I'll talk more about that in a minute when we go into the deep dive. But that was the source of the radiation storm. It was not this filament that erupted. However, that being said, the particles, the solar radiation storm that's coming toward Earth is also now being driven by the shock wave in front of this structure. So that radiation storm will not completely calm down until this solar storm reaches Earth, which won't be until August 1st. So those of you who are hoping that this radiation storm is going to die quickly, not going to happen, because the shock wave in front of this big storm actually energizes those particles. So strangely enough, it helps keep those radiation storms energized and makes them linger for a longer period of time. Once the shock wave of this storm, of this eruption hits us, then things will really start calming down. I think we just dropped below the S1 level, but I don't know if we're going to drop much more below that. But we'll talk more about that in a little bit. So this is, I think, region 3386. This is down here, region 3380. Both of them have been firing solar storms quite frequently. And I don't know if I can show it to you here. Let me see. Let me slow this down. I might have to show it to you on my. I also have 211, the pink sun up, and there's reasons why we have different colors. So there's a beautiful shot of 3376 firing that, you know, that gorgeous structure off to the west there. And then you can see this structure, this filament eruption right here, right? But then just after that, there's this weird little, let's see if I can find it, right? You can barely see it. I'm going to try to point to it, and I'm going to wiggle it back and forth. Right here, there's this little thing that lifts off from this 3386, I believe. Right here, you can't really see it in very well, but it's a tiny little filament that lifts up. Oh, that's interesting. I just had something fall. It just barely lifts up like this, and you don't really see it, but there's a lot of synergy that's going on in these regions here. And if I flip to the pink sun, you'll be able to see it. And I was looking for something, because you see all this? Watch this. I'm just gonna, and I'm sorry for jumping around, but I just want to do this quickly because I want to get to the bottom line, what I call the bluff, right? The bottom line up front, so that those of you who don't have time can leave quickly. But do you see, watch this area in here, watch this area in here, watch them dim, right? Watch the changes. Do you see that? And do you see right up in here especially, and right down in here especially? See these areas? This, guys, is another solar storm launch, okay? This one was not caught, okay? I don't think this one's connected to it, but it might be. But this thing, because of where it is in the Earth-facing disk, it's in the Earth strike zone. So we have not only that big filament, which was right here, okay? This is a different colored sun, so it looks different, because we're looking at higher in the solar atmosphere, not so close to the surface. This is that filament that erupts. Boom, right there it erupted. And then shortly thereafter, watch, whoosh. You see this? This is the second eruption. And yes, there are two halos, okay? NOAA and NASA caught the first one. They caught this big boy. But the problem is, if you're not super careful, really super careful, and look at every puff and woof and whisper and whatever sound you want to make, you can miss these structures when it's solar maximum. I mean, it's just unbelievable. And the coronagraphs, bless their hearts, they're trying hard as they can, but they can only focus really on one eruption at a time. And so the wispy ones like this get missed. Now, how much is that going to add to the solar storm we've got? Don't know yet. Don't know. But I do think it's going to extend the solar storm that we've got. So aurora photographers, things may be looking up for you. Okay, so what I'm going to do now, actually, I'll go ahead and, you know what I'll do? What I'll do is I'll do one playthrough of this color sun which shows more of the solar atmosphere, and I'll walk you through what's happening just really fast. So here's that big solar storm. You're going to see that big, how I knew that those ones on the side were erupting, you can see stuff down here and stuff up here. Okay, so that's how I know those are connected. So that was that solar storm. This is going to launch here soon. And when it launches, you see there it goes. There's a filament eruption. Now watch this area in here. Watch it a little bit longer. And whoosh. Do you see all that weird stuff with the dimming regions up in here? Yeah. So that's another solar storm that's coming toward Earth. And it is partly, it's mainly going to the east of Earth, but it is coming. Okay, and then we've got, of course, the other activity. We had that other thing. This is what that other solar storm looked like when it launched, and that solar flare from region 3376. I think you can see it. Come on, give us something. There it goes, right there. So it doesn't look exactly the same as it does on the red disk, but there are reasons why we look at these different wavelengths, because I could hardly see anything of that second solar storm being launched, that second Earth-directed solar storm being launched from the red disk. I have to look at it in other colors. So anyone who wonders why we're getting that, why I look at these sun in different colors, this is the reason. It's why scientists do what we do. Also, for those who may not have ever seen or not super familiar with these types of imagery, right now we are in eclipse season. So when you see the disk go black like this, NASA's not hiding anything. This is the moon, guys. This is the moon eclipsing the instrument. We can't see through the moon. So when the moon passes by, imagery goes dark, okay? It's not this, because this is an Earth orbiting satellite. It's not like SOHO that sits out at L1 beyond the moon. This one is in between Earth and the moon and the sun. So the sun, moon, satellite, Earth, okay? So SDO gets eclipsed. We go through the eclipse season several times a year, and we happen to be in it right now. And it's kind of unfortunate, but we have to deal with it. Okay, let me go ahead. For those of you who are in a rush, let me go ahead and put the bluff up here, my 5-day outlooks. I think this one is already looping. Okay, so again, this is just kind of a review of the disk mainly. So there's the filament that's going to erupt. You can see, yes, it's 3386, yes, and 3380. 3376 is already behind the limb. 3379 is one that we're watching as it goes away. Several of the big players, we'll talk about them a little bit more in a minute, but really, you can see there's actually several different filaments that we do continue to watch. This was kind of a snake-like filament that was almost completely connected all the way through. We are watching some of these other regions for eruption, but right now there's really only 2 Earth-directed solar storms that we're watching right now. As we go to, well, now we're in mid-latitudes, but it'll go to high latitude in a sec, and I'll stop it when it does. Okay, pause. Okay, so whoops, let me let it all the way in. Okay, there we go. So right now at high latitudes, NOAA is expecting major storm conditions, mainly from some fast solar wind that's kind of petering out. We're probably a bit on the stormy side at high latitudes. There might be a little bit of aurora going on, but things are going to calm down just a little bit. Not too much at high latitudes, though, simply because we're going to be on storm watch here over the next 24 hours. But when the storm is expected to hit right about the 1st, okay, and when I go into the deep dive, I'll show you the model runs so that you can see a little bit more of how the 2 models really compare. They compare beautifully this time. I think NASA and NOAA were definitely talking when it came to this big filament eruption. But at high latitudes, we're expecting, or NOAA's expecting, major storm conditions with about a 60% chance of a severe storm, or at least a major storm, if not a severe storm. So high latitudes, you definitely could get some decent activity, and that will continue easily into the 2nd, possibly into the 3rd with this new solar storm, right? The one that seemed hidden in there that did not get modeled. So this may be a bit of a conservative estimate, actually. We may be storming a little bit longer than anticipated, because that is not included in my 5-day outlook. I didn't catch that storm until today. So just letting you know that, it's full disclosure. But we should be calming down sometime around between August 2nd and August 3rd. But it is a very good chance for you guys to get some aurora up there at high latitudes, so enjoy. And then when we get to mid-latitudes, the picture still looks pretty good. We are dealing with that fast solar wind, which really kind of, anytime you rattle the Earth's magnetic shield, it makes it that much more sensitive to being further rattled. So that's a good thing if you're looking for aurora. Because now we're going to get hit by the solar storm here right around the 1st. you know, it's actually going to bump us up to storm levels a lot faster. Now NOAA's only expecting a G1 level storm, so minor storm conditions, which is about right, which would be, so those of you in the upper tier of the United States, for example, maybe down to mid-tier of states, that maybe, it depends upon if the southward field, if there is southward field in the storm, and if the southward field is sustained. Of course, we won't know about that magnetic orientation until the storm hits. So these are, you know, hopefully, if we get some southward magnetic field, these are right in family. It could be a little bit worse. NOAA's giving us about a 15% chance of a major storm if conditions are favorable. And then again, we're going to be storming and settling down a little bit faster than we would at high latitudes, going back into unsettled conditions, possibly still at active conditions now that we see that there's a second storm coming. So that's going to be good news. We might actually extend a little bit into the second at mid-latitudes for aurora. So good, you know, I would definitely, if you're a chaser, if you can get to high elevations, if you can get to, you know, places that are further north, if you're in the northern hemisphere, or places further south if you're in the southern hemisphere, and dark skies. Find clear skies and dark skies, and you might be pleasantly surprised. Or watch all those wonderful webcams that keep sprouting up everywhere. It's amazing how sensitive webcams get. And even if you can't see it with your eyes, go to the horizon, take long exposures with your camera. What you may not be able to see with your eyes can look spectacular on film, on a digital camera, because these CCDs are so expensive and extremely colorful as well. So definitely, it's definitely worth a chase. And then, of course, by about August 3rd, you know, we should be back down to pretty much normal conditions. That is unless this sun decides to launch something else, which is very possible. So, you know, when I'll make these 5-day outlooks that go out that far, but, you know, they really get dicey out here because this is why NOAA and NASA don't bother. I stretch it out. Someone actually asked me to do a 10-day, and I went, are you kidding me? I can't even get a 5-day right. So just understand that there's just so much activity on the Earth-facing disk right now, especially with these new regions rotating in, and they are definitely solar storm producers. We've already seen it. So we could easily get a lot more chances for solar storms here over the next, you know, week or two. Okay, so let me kill this one and now go to, let me open up the other. Which one is it? This will work. So, and let me make it loop. So here is your solar flare and dayside radio blackout outlook, as well as the radiation storm outlook. What I'm showing you at first, though, is really just where the regions are on the disk. Our big flare players are mainly 3380 and 3386 right now. They're the ones that are driving all of the R1 to R2 level radio blackouts. Do I have 91? Yeah, I have 91 on there. This is likely, 3391 will likely be a big flare player as well. It's just hard to tell as of yet. In fact, let me see if Swipsy's, what has Terry done? Terry Spencer, one of my favorites. He's only got it about, he doesn't even have it as a big flare player. He thinks it's only about a 10% chance of M-class or C-class flares, which means either 3391 just blew its, I don't want to call it that, that's a rude way to say it, but either exhausted itself, maybe sweet and say it that way, exhausted itself during that last big eruption, or we have yet to really see all of the regions that, you know, all of the activity rotating further onto the disk to get a better view of it. It's kind of hard to assess when something's on the limb how much of a big flare player it might be. But I do believe we're going to have more flare players rotating into view. So I think over the course of this week we're going to see a lot more activity, and risk for radio blackouts are going to stay up high. So as a matter of fact, it'll stop. As we take a look at our solar flare and dayside radio blackout outlook over the coming week, we are keeping that solar flux awfully high, right? I don't know if we're going to get back up into the 200s. Not yet. Not for another maybe 5 or 6 days when region 3363 might rotate back into view. We might get back up there again. But you're going to start seeing a ramp up. And we're definitely sitting in the moderate noise range for radio communications, especially, you know, on Earth's day side mainly, because that's all what solar flares, you know, affect. They don't affect the night side. So if you're getting sick of dealing with radio blackouts, just do DXing on the night side, and you at least won't have to deal with that. Can't help you with lightning, but can help you with solar flare noise. NOAA, over the course of this week, is going to be giving us about a 40% chance of the R1 to R2 level radio blackouts. That's an M1 flare to an M5, or essentially an M5, with about an R2 level radio blackouts, an M5, up to an X class. Now we're only getting about a 5% chance, which is of an X class flare, which is an R3 radio blackout, R3 level radio blackout, and that's probably going to stay that way for a bit. I would say easily over this 5 days. I don't think any of the regions even that are going to be rotating into Earth view over the next 3 to 5 days are going to be a big deal. Region 3363, though, that's that old region that gave us so much trouble about a week ago. When that region rotates back into view, trust me, I'll be taking a look at it, and you'll know if you see this risk go up, you'll know that region is likely going to be the culprit. Here in about 5 days. So it's kind of a flat forecast. You're just dealing with a moderate noise, and that's because there's just so many active regions on the disk, and these big flare players are going to be replaced by some others that continue to rotate into Earth view. Now, as we switch to our radiation storm and polar aviation outlook over the coming week, we are dealing with right now an S1 level radiation storm. It was at an S2 level just a day or so ago. But likely this is going to continue. I think we've dropped just now below the S1 level, but it's probably going to hover in and around there. So this forecast isn't all that off. By the 1st, though, we should be back down to an S2 level, or an S0 level. We'll still be in the D2 minor range for you aviators, those of you who understand that what the ranges are, and I'm talking at a flight level of, what is it? It's 11,000 kilometers, so 39,000 feet. I think that's flight, what is that? FL 390, I forget how that works. But yeah, we're talking about a typical cruising altitude of a domestic flight. That's where these levels are. And we probably won't drop down into the D1 normal range until about the 3rd. I'm saying maybe we'll drop down by the 2nd, but you frequent flyers just know you're definitely dealing with elevated levels right now, possibly S1 storm levels. And we do have, right now we have about a 40% chance, it's dropped down to about a 40% chance of popping back up over that S1 to S2 level over the next couple days, and then that risk will continue to drop. And likely until this region, 3386, rotates to the sun's west limb, and then you might see that risk rise again. So just understand, if you're a frequent flyer or you're a high-risk passenger, you're dealing with that. You're also, and this does include air crew, of course, you're just dealing with that, so please take this into consideration in your flight plans. And of course, radio communicators at the poles, if you're in the northern or southern hemisphere, near the poles at very high latitudes, you are likely dealing with extra issues with your geolocation and your navigation. So, and hopefully that's going to die down by the time the 3rd rolls around, so just hang in there. And that's about it for the quick space weather snapshot. So those of you who are, I'll take a bout of questions for the moment. You know what, I'll put up the other one. I'll take a little bit, no, I'll keep this up here. I'll take some questions for you before you guys, before some of you, if you have to leave. If you have to go, then, it is what it is. But then I'll jump into the deep dive after I take some questions. So hopefully that was clear enough, and if not, I can clarify. Okay, Smart Tool, I hope you're not one of those Satan worshipers over there at NASA. No, not the last time I checked. I don't work for NASA, I work for me. So, although NASA respects me, which is nice, I've got a lot of colleagues there, so that tells you what it tells you. August 1st until when? Till about, at least through at least all of August 1st, because this thing may actually hit late on the 31st. NASA's model actually shows it hitting just a skosh early before midnight. On August 1st, so just in like 11 something UTC on July 31st. NOAA is saying it's a little bit slower. Yeah, I kind of agree with NOAA. I think it'll be a little bit slower, but I've been wrong many times. So just kind of get ready in the window of the 31st through about the 2nd. And that's probably where the big window is. It all depends upon what latitude you're at and what location. If you're in the UK, it's going to be a little bit harder for you to see aurora. That side of, across the pond is a bit harder to see. the Western Hemisphere gets, we got the lucky part because the auroral oval dips a bit lower for us. So it's easier for us to see aurora at lower latitudes than it is for you guys over there in Europe and whatnot. Deep dive. Yes, I will get into the deep dive soon. How is solar max determined? It depends. It depends upon your methodology. And it depends upon whether you're calling it a moment in time or you're calling it a phase, because it's both. Just like solar minimum is also a single moment in time as well as it is a phase. So it really depends upon how, what you're really going after. But when you do a model of the solar sunspot numbers, it's very easy to find it retroactively, because once you have an entire cycle, well, you just draw a curve through it and find where the max is. Now, many of these solar cycles recently are having what we call asymmetric, hemispheric asymmetry. And so what happens is that the northern hemisphere and the southern hemisphere reach solar maximum at different times. And so you're actually seeing a double peak in the solar cycle. So you actually have two maxima, right? Because the northern hemisphere and the southern hemisphere argue. No, I want this to be the max. No, I'm going to wait till this time. It happens. And I won't go into the details of that, but I have talked about that in my mini courses. So hopefully that kind of answered the question. Okay. Question, will this blackout kill 10 meters? Now the blackout, the radio blackout on Earth's day side, yes, absolutely. Any of the radio blackouts that we're getting from solar flares, it will kill 10 meters. If you're talking about the solar storm hit, that's likely, it will disrupt 10 meters, but it also will light it up quite a bit, especially near the gray line. 10 meters is almost like 6 meters, like the magic band. You can get some amazing transhemispheric DXing during solar storms, and just talk to people that you never would have expected to get contacts from. The problem is it's sporadic. So if you're going to have QSOs, have short ones, because you may lose someone really quickly, long enough to say hi, bye, and then you're like, oh crap, I can't get them back anymore. It's very, very sporadic, because that's what solar storms do, is they really make that ionosphere very, very fun to play with. Also, the ionosphere, when the solar storm hits, it'll affect the night side first, but then effects will propagate to the day side over the next day or so. So even if you're on the day side, you can get impacts from the solar storm. Sadly, impacts from the solar storm mean that you should switch to lower frequencies. When you switch to lower frequencies, that actually helps your propagation, especially on the night side. But that's exactly the opposite of what you want to do when you have a radio blackout on Earth's day side. You want to switch to higher frequencies, because those can ride out those radio blackouts better. So it's kind of it's a mixed bag. Space weather is always a mixed bag when you have a lot of activity like this, because the phenomena are so different. Hopefully that answers that question. Mid-latitude at what cities? That's a really tough question, and I didn't see who saw it. I just saw the last line. That's a really tough question to answer, because we don't know exactly when the solar storm is going to hit. We know kind of early on this day, but it's, the Earth is always rotating, right? So if it hits when the UK is in the daylight, well, not those cities. It's going to be whatever's on the night side of Earth. And just a few hours later, there's different cities on the night side than there were on the day side. So that is really, really tough to say. I can't say with any certainty. I can just kind of give you a little bit of a latitude band. Optimistically, this will easily hit the middle of the United States. Okay, as far south as that, and obviously everything above it. That's the optimistic hope. And in the UK, Netherlands, possibly Germany, if you're really careful and have really sensitive cameras. But that's optimistic. So just, but you'll have the best way to know is to follow the massive contingent of people that we have on Twitter, because that's where all the now time reporting is being done. And likely there's an Aurora field reporter in your city. The group of people, the community has gotten so large over the course of the last decade that we've been doing this, that there's really a ton of resources out there. So it really behooves you to get, sadly we don't have the real-time reporting on YouTube, but it really does behoove you to at least lurk on Twitter. Even if you don't have an account, just search and just, look for Aurora. And you'll see a lot of people in the community posting their pictures. They're very, very helpful. And the community there is just very wonderful. So please join in. Hopefully that helped. Okay. Let's see. Oh my goodness, things were moving quick. Okay, will they be shutting down satellites to protect them from this? Likely not. I mean, I can talk a little bit when I go into the deep dive. I can talk a little bit more about what satellite conditions look like, at least in GEO right now. Do I think that they're going to not launch any Starlink satellites right at the moment? Probably not launch any Starlink satellites. That would be, you know, if they do want to launch them, hopefully they'll get them above 375 kilometers. Don't launch them down the 200s, you'll be in trouble. So hopefully they'll be either upping their orbit insertion to at least 375 kilometers, or they will just delay and just kind of wait. But it's, you know, it's a big trade space. So space weather just is one component of a massive trade space. And if it costs too much money to delay because of space weather, they're going to launch. And they're just going to do the best they can and, you know, cross their fingers. I'm not sure Elon does that, but, you know, it is what it is. Okay. Let's see. Long as it doesn't hit way down in Australia and New Zealand, yeah, it will. My goodness, we had a storm just back on the 26th. As a matter of fact, I'll go to it real quick, and then I'll jump into the deep dive. Just this storm that we had here, this is a KP index over the past 10 days, and we had a KP of 5, right, or not even 5, 4.66 I think is what it was. And there was aurora seen in Victoria. I mean, that's just how sensitive the cameras are getting anymore. Our eyes may not be able to see it, but you definitely can see it with the sensitive CCDs. And remember, aurora always looks more dim, and it looks more pale with your naked eyes. So definitely bring a camera along and take those long exposures. You will be very happy you did. Okay. Oh, thanks, Gareth. That's kind of you. Isn't she just amazing? Okay. Planes do not require satellites to fly. Agreed. The only issues that you have is if you're at high latitudes and you're using GPS to help do position location, or you have to talk to air traffic control and you happen to be using HF comms. You know, sometimes it can be issues. I do know that people in Alaska are very space weather savvy. People in Sweden are very space weather savvy when it comes to these airlines, so airports, pilots, as well as air traffic control. And they have to be, right, because space weather affects high latitudes more than lower latitudes. But no, it doesn't affect the planes unless you have a big radiation storm, you're flying at really high altitudes, and then you can have some avionics issues. But, you know, for commuter planes, smaller planes, not a big deal. Commercial planes have a lot of inertial navigation and a lot of backup systems that help them. But I do know from anecdotal reports that pilots do have issues, especially when they come into land. When there are big issues going on and GPS signals are being disrupted, you know, and I mean by disrupted, the reception of them are being disrupted. This GPS signals are just fine. The satellites are just fine. It's just that you can't receive them well. There have been times where pilots have had to use backup systems to land, and there's a lot of anecdotal reports of that. It's not often, but it does happen, especially when aurora is near airports. So these guys know that, thank goodness, and but it doesn't affect the airplane. It's not a dangerous thing for airplanes, so don't worry about that. So yes, that pilot was correct. I missed who it was, but is this going to affect my Starlink satellite internet? Only the radio blackouts if they're up at 12 gigahertz. And you know what? I have not checked to see whether or not some of these radio blackouts are that high. I doubt it because they're low-level. Most of them have been low-level M-class flares. Now that region 3376 has rotated to the sun's far side, we're not seeing any of those big M4, M5 class flares. So likely over this next week, you're not going to have much issue with Starlink. Aurora doesn't really affect Starlink nearly as much. The issue that you'll have is you might get disruptions if the storm is is big enough that it's causing more drag on those satellites than they'd like, and that could disrupt things for a little bit. But I don't think you'll see all that much, not right now. So it's just the new launches that have to get through the atmosphere that's a bit of a problem for them. I thought I heard this was an M-class flare. Did you miss an X-class? No, I don't think there was an X-class flare recently. As a matter of fact, I'll go the last 7 days. We'll take a look. And then I'll drive, yeah, no X-class flares. X-class are this high, right? So the highest you've seen have been that was some M4, M4 and M5. This is, I think both of these were from region 3376, which is now gone. So no M-class flares. Now we're just sitting at M, M1, M2, and they're short duration for the most part. So, oh, good. Thank you, Richard. I'm glad you're new to the channel. I'm hopefully this isn't too big of a deep dive here. But yeah, I do this from time to time when we have big storms and I don't have time to do a formal forecast before the storm hits. Okay, guys, looks like I can get into the deep dive. Okay, what is it with all the jokers? Yeah, well, I bet you Mike and Jerry have their hands full right now. Yeah, everybody please try to keep it on topic. There are people here who are very serious about space, come on, about space weather and wanting to just get the information. And this is cute. Why aren't you letting go? I can't get this to let go. Okay, that was interesting. Hello. All right, so I'm trying to think, where should I start? I guess probably the biggest thing I should start with is the solar radiation storm. I will talk about, I think what I'll do, let me just make sure I know where I am. Okay, this is the 28th. Let's see, what is this? Is this the 28th? Yeah, okay. So let me restart this. Okay, so just so that you know, this is a DRAP model. It actually shows where these solar flares are occurring. But you'll start noticing about late on the 28th, you'll start watching the high latitudes start racking up. This is when that radiation storm started from region 3376, and now is it, come on, 15, 16? Right about now, you'll start seeing it ramp up. There you go. So that's the radiation storm that's beginning to ramp up on the 28th. It wasn't super strong at first, and then it very quickly, as I go to the next one, this one? No. This one. As I go to the 29th, you can see it actually ramped up pretty strongly. It started getting pretty intense. We were having a lot of degradation on especially low frequencies, but just up saturating it beyond 35 dB of dB down of noise that is impacting radio communications and navigation, and that's going to continue. Now things have kind of lightened up a little bit. It's not as bad as it was, and I'll show you the timeline here in a minute. But it was not feeling very good for a little bit. In fact, I'll go here, toggle full screen. There we go. So this is the actual radiation storm timeline right now. So you can see it actually hit right about 1700 hours. This is from that big blast on the west limb, ramped up past the S1 level, which is this level right here. The S2 level is, if you can see it, is right here. So we just skirted over it for a short period of time and then hovered around it. And we're finally dropping back down. We've just dropped back down past the S1 level, and I really don't think as this continues, I don't think it's going to go straight down. I think as that shock from that solar storm gets closer, you're going to see it kind of level off and then slowly go down. So that's why I'm saying we're going to probably stay in and around this period, elevated levels over the next couple days before this solar storm hits us, or over the next day. And then once that solar storm hits us, then you'll see it decline quite a bit. It wasn't really a hard spectrum, so for those of you who actually recognize that you have high energy particles in here, it wasn't super hard. So the issues with airlines, it's not that bad. It's just mostly low energy particles. So not super bad when it comes to being a radiation storm, but just the dose is just high enough to warrant having high-risk passengers pay attention, especially during international flights and that kind of thing. So that's where we are on that. I guess I'm having the same problem. It will not release. And I hit escape. I can't believe it. It's the strangest thing. Usually it doesn't do that to me. Okay, so that's regarding, that should give you an idea of where we are with the radiation storm. I guess the next thing I can show you is going back to these two eruptions. So this is the filament eruption. I want to show you the other storm that's coming. Oh, actually, I'll show you this storm here. Let me remind you of what this filament eruption was. Let me show you the NASA and NOAA models so you can see those for the moment. So this is some of that deep dive that we were doing. And which one do I want to show you? Annotated MP4. Okay, so this is going to be the NOAA version of the model. And I'll make it loop just so I can show it to you over and over again. Okay, where can I put this so that it'll... You're going to disappear on me? Okay, good. All right, so, whoops, let me stand on this side. So this is NOAA's version of the solar storm prediction model. Top panel's density, bottom panel's velocity. You're looking down at the sun from the North Pole, and Earth is right over here to the right, okay? And as you watch, you'll see that solar storm being launched. You can see it here. The bulk of it is coming to the east of Earth, right? But you do see that there's a decent part of it that hits, and I'll actually back up. If it'll let me. Let's pause. Let's back up just a smidge. You can see that's actually a pretty decent finger of this is actually sticking, you know, to the west of Earth. And I agree with that assessment. This is not just a grazing blow where maybe we'll catch it, maybe we won't. I think in this case we actually really will catch it. And I'll talk about the coronagraphs here in a second and why they made that decision. And yeah, they're showing it being a pretty decent bump. And that is possibly very true because we have a lot of material in this filament. Anytime you get filaments erupting, unlike a big solar storm launched with a solar flare, when you get filaments erupting, oftentimes you get these dense structures. It's a bit more dense than they would otherwise be. You know, the other structures can be more wispy. And we have a wispy structure that's going to be following this one. It's just not modeled here. But as you can see, the impact that NOAA is giving us is really closer to about, you know, 600, you know, UTC on the first. Okay, so NOAA's version is that it's a little bit slower, with the speed of the storm being only about maybe 450, 500 kilometers a second. That's why it's only going to be a G1. Now, if the structure is extremely dense and has a lot of southward magnetic field, even having a slower speed, like 450 kilometers a second, it can give us a decent storm. So, you know, we really won't be able to tell until the storm hits us, but we'll definitely update you as soon as we know. Sadly, we can't predict that ahead of time. We just don't have models that can do it quickly enough. Okay, where is my... Oh, there it is. So now let me show you NASA's version. Hello? Okay, good. So again, this is a solar storm prediction model. It is, but now we're only looking at density. But we once again are looking down at the North Pole with the Earth being off to the right. This is a slightly different version of the model, but you can see again the solar storm really being launched mainly to the east of Earth. And let me stop it. You're seeing the impact essentially a 100 UTC on August 1st. The actual impact is a little bit earlier than that. The resolution of these model runs is in here. You know, for animated purposes is not as high as the actual, you know, run. Obviously, the real run can get a much higher resolution. So the impact time ends up being just shy of the first, and so it's going to hit a little bit earlier. As you can see from the north-south cut, once again, it's, you know, this isn't a glancing blow. This is going to be a decent hit. And when you look at the impact footprint, this is a way of kind of looking at like a splash. If you imagine the sun shooting something out at you, and you put like a window, right, and the thing hits the window and smashes onto the window, what would it look like? Well, there's the window. Okay, so here's Earth. North is actually this way, and south is that way. So it's mainly going south and mainly going east of Earth, but Earth is still in that smash, you know, in that splash that we see. So is this going to be a better hit than what we've seen? Most likely, yes. And we don't have any real fast solar wind pushing it out of the way. So I don't see it being deflected. I think this is going to actually be a good hit. But once again, there is another solar storm just behind it. And I'll tell you why I say that. Okay. So for that, let's go back to the coronagraphs. Okay. If I can find them. Where are they? They're in here somewhere. Okay, good. Okay. Before I do this, I want to show you the whole coronagraph event for the first one. Oh, don't I have you labeled? Yes. Come on. Okay. Sorry about that. And let me loop it. All right, so I'm showing you this version mainly because it's got both the 28th and the 29th in it. And I think it's just going to keep going over and over again. So what we're looking at is the view from Earth. This is the intensity image, which is just the raw imagery. But sometimes you can't see you can see the puff, but it's not really highlighted. But a difference image where you're taking successive images from these intensity images, from the raw images, and you're subtracting them so that you can see the differences. So when something moves, it either gets very white or very black. Yeah, what that does is that highlights the difference, it highlights features, basically, that you can't really see very well. And so what we're looking for in this as it plays over and over again, hopefully it's not making you dizzy, what you're looking for is something like a ring that goes all the way around the sun. And sure enough, you can't really see it in the intensity images, but you sure can see it in the difference imagery. You can actually see that halo coming out. As a matter of fact, I'll stop it. Let me see. That's probably a pretty good screen to stop it on. Do you see this? I'm going to trace the outside of it. Okay, it goes all the way around. Of course, the bulk of it is here, down here in the southeast, which is why we have the model showing it's going to go mainly to the southeast. But you can see that halo coming all the way around, and maybe even all the way around here. You can this is where it's the weakest. But you definitely see something that's basically an entire halo. That tells you that, yes, this thing is definitely headed toward Earth, and we are definitely going to get a decent storm from this one. Now, this is the first storm. And as I've said, for those of you who've been with me many times when I talk about the coronagraphs, I love them and I hate them because they basically focus on the most intense thing in the sky. And when they focus on the most intense thing in the sky, what they do is they change their exposure so they don't overexpose the most intense thing in the sky. That's wonderful if you're looking at the features of the most intense thing in the sky. But if you've got something that follows that is a lot weaker and wispier, suddenly it becomes invisible. And that's part of the problem that we had with this other eruption. So I'm going to go to this next day and I'll show you, actually I'll remind you of the eruption that we're looking for right before we go to the coronagraphs. So we have this back on the 28th. Here is that filament eruption, right? Right, we know that one. Okay, and now we're looking for the dimming that comes over in this region, all around region 3386. Not even a day later. Look, see this? You see the dimming here? Right? See all that? Kind of a change in here. And in here you see dimming. See, kind of a weird thing. And you see it in here and all in here. See it all? See how much that dims all in here? Right? All of that, along with the puff and everything else, that is another solar storm. Okay? And this part may be involved. It's hard to say. It's hard to say if this is connected. It is definitely timely, but it's hard to say if it's connected. Nonetheless, even if it isn't, this big thing is definitely enough to make us want to look for another halo. Okay? So looking for a halo that comes after, this is the 29th at about 9 o'clock UTC-ish, maybe 50, oh no, sorry, a little bit later than that. Maybe 14, anywhere between 12 and 14 is when we could start seeing it, maybe a little bit later, right, all the way through maybe to the end of the 29th. So when I go back to, here we are. So I'm going to see if, I think this will probably just play. So this is now the 29th, and something I'll point out before we start looking for the big solar storm, the second solar storm. Look in the intensity images. Can you guys see this? I'm going to zoom in quite a bit. This is why I don't like radiation storms when it comes to doing forecasting. Do you guys see all this snow? Do you see this stuff, this mess? Do you notice how it starts out kind of quiet, but then there's all this static that kind of builds up a little bit? This is the radiation storm. This is how it affects instruments, okay? This is actually not even a strong radiation storm. That's why the sparkles are not that big a deal. They're just like little mini fireworks in the sky. But could you imagine if you're an astronaut, this is what their eyes see. So when they close their eyes, they see that when there's radiation storms. So I guarantee you those astronauts spent, especially when this thing was at an S2 level, they probably spent some time in the water storage at first, wondering if this thing was going to get bigger. They're probably no longer in the water storage, but they might, if they can, I imagine they recognize that there's still a radiation storm ongoing. And I wouldn't be surprised if many of them are spending as much time as they can under the water storage to help shield them from this junk. Because, you know, you can see it hits these optics and hits the instruments, and that is exactly what it's doing to our bodies as well. So radiation storms are no joke, guys. Those astronauts out there really need to keep themselves protected during solar max. This is why we're worried about Artemis. Okay, so luckily the radiation storm isn't too big a deal, and in difference images, you don't really see it all that much, okay? So that's mainly because this isn't that strong a radiation storm, thank goodness. But when we take a look at the details here, so there's one solar storm that launches. Here is the halo coming, hold on. Oh, whoops, I gotta start there again. Okay, oh, you didn't stop. Oh, that's right, because I'm not a movie. Sorry, hold on, we'll wait for it to loop. And there, okay. So that, let me go back. This, of course, is the big solar storm that we're waiting for. Okay, that's the one that got modeled by NASA and NOAA. Okay, now let's just move forward a little bit in time. Right, so we're looking at the same type of difference imagery as I showed before. And there is this, now notice, do you notice how clean this looks all of a sudden? Okay, I'm going to back up just look how ratty that looks. See how ratty that looks? You know why that looks ratty? There's nothing going on the disk, and what the coronagraph is doing is it's really upping its sensitivity. Okay, so it's really trying to resolve all the dim features. And so you're getting all this, but it causes the noise to go up, right? So one thing you always look for in a coronagraph image is what is the noise doing, especially on these difference images. And when a big structure, a big bright structure gets launched, watch how smooth this gets, because it stops down its sensitivity and the noise goes away. Right. Look at that. Okay, wonderful, because now you're not overexposing this. This isn't just a white blob, it's actually got features in it. That's great and that's wonderful, but what it does is it makes it hard to see any of those fine scale features anymore, okay? Because all those fine scale features that we just looked at just a second ago, that was 724. All these fine scale features, do you see them? They're still there. You just can't see them. 736, what? Suddenly the solar wind got really quiet and pristine? No, the features are still there. If you look hard, you can still see some of those features, right? You see them all? But you really have to look now. They don't pop out at you. And that is part of the problem. So when a really dim or weak solar storm gets launched, when the coronagraphs stop down like this, you better really kind of recalibrate your eyes to look for things that, you know, you otherwise might overlook. So this big solar storm caused some issues for us because this thing is still going. And as it continues to go, remember I said we need to look for a halo or something in and around noonish on the 29th? What are we beginning to see here? What's this coming out? Do you see? What's this? What's this? Is there something here? Maybe? And I wish I could, let's see if this is another, okay, this and this, don't know. Look, something in here? This was later, but it's still in that range that we're looking for, okay, before late on the 29th. So we're seeing something. Now, is this modelable? No. Can you model this? I mean, you can try. With any level of confidence? Not really. But is there likely a storm coming? Yeah, there likely is. Now, is it going to be strong like the first one? Probably not. But what it can do is it can actually cause an enhancement, right? And if I had time, I'd go back and I'd look at stereo data, which I'll probably do after we're done, because I haven't had a chance to look at stereo data to see if I can see in that coronagraph, in the Core 2 coronagraph, if we can resolve this any better. But just like the Soho-Lascaux chronograph, it does the same thing, right? It stops down and it makes it difficult to see some of these dim features. So I will likely go back and take a look, and then I will possibly modify some of my forecasting that I've done here. But to me, this looks like there might be some structure, especially in here. So just extremely hard to tell because we're at the tail end of this thing. So expect to have that solar storm hit on the 1st, and expect the bulk of it to be there, but don't be surprised if things kind of linger and there's some other junk that is scrambled up in there at the tail end of it, because likely we do have another storm coming, okay? I'm trying to think, what else do you guys want to see? I think I went through everything. Oh, far side. Yeah, I do want to show you the far side. Okay. So I'll do this and then we'll take more questions, okay? And this one, sadly, I can't stop. Whoops, I'll slow this down. Shrink it. I can't stop this because it's an animated GIF and I don't have one prepared for us right now. Okay, so what we're looking at, because we don't have, stereo A, some people have been asking me recently, how come you're not using stereo A for far side imagery anymore? Well, it's become clear to me for the last, I don't know, maybe couple months that stereo A really is not being all that useful. And its usefulness is just really, really limited. You can just maybe get a small sliver, maybe a day in advance notice of what's going on in the east limb compared to what you see at Earth. Because stereo in its orbit is getting closer and closer to Earth right now. It's going to pass Earth, and then it's going to be advanced from Earth again. And it will start seeing more of the far side of the sun past the west limb. So regions that have gone through the Earth-facing disk and then are going behind the west limb, stereo A will start seeing those longer than we can. So we'll get a little bit of imagery of the far side, but that's probably not going to be until about 2026. 2025-ish, maybe late 2025 into 2026. That's when stereo A will likely be really useful to us again. And I probably used it a bit longer than I should have, really, when it comes down to it, just because there just wasn't all that much that stereo A was seeing. But I finally just had to kind of give up the ghost, and just because I was resorting, if you noticed, I was resorting far more to the helioseismology, the far side viewer that JSOC puts out, far more than I was even relying on stereo. And so that's really the way it's going to be for the next, maybe couple years. So in my forecast, what you're going to see is that I'm going to be putting up the HMI diagram, so you'll see the front side of the sun, what it looked like 2 weeks ago. Because when we look at all the far side, which is this gold stuff here, this is all far side seismology data. What resolves that better is looking at the sun 2 weeks ago in what it looked like when it was in Earth view, because now it's rotated completely around to the sun's far side. And we can see from the dark patches which one of those old regions, or which several of the old regions that we did see 2 weeks ago, which ones are still active, because the dark patches really tell us that, okay? So for instance, this was a little while ago, as you can see back on the 14th. But so this is the stuff it's on the Earth side of the disk. And as we come back over here, you can see that was region 3363 that rotated to the sun's far side. And you can see it is still active. See, as of today, basically, that region is still going. So that's region 3363 when it was on the Earth side of the disk. That's why I have good imagery of it here. But then when it rotates to the sun's far side, it goes gold. So that was the parting blow that it gave, and now it's on the far side. And it is still going strong. And as it stands right now, it's got about another 4.5 to 5 days before it reaches us back Earth side. So we've got. Let me just go backwards a little. So this is the current imagery right now on the 30th, and you can see region 3363. Plus we've got a couple other older regions, including, well, we don't really see region 3376 yet. I don't think we see that region. I think that region is over here. So This may be region 3372. Remember, there's a whole cluster of regions that gave us a lot of trouble just about a week and a half ago or so. And that's what these regions are. So some of these regions are actually surviving their far side passage along with region 3363. So my goodness, I mean, we just got some new interesting regions that are going to be giving us some trouble, and now we're watching these guys survive. So the longer they survive, you know, that's another hint that we are getting very close to solar maximum, because we're seeing more and more large clusters, either sunspot, you know, clusters or groups of sunspot clusters that are surviving longer, persisting longer on the sun, and they're larger. So definitely getting close to solar max. Definitely going to be an interesting next couple of weeks, or next, you know, at least 10 days, I would say. And the flare risk will likely go up before it goes back down. So hopefully that gives you guys some insight as to what's going on and what will go on over the next, you know, maybe 10 days, a few weeks, or a few days to 10 days, both Earth side and far side. Okay, let's see. I think that's about it. Unless you guys have very specific questions, I think I'm very done. I mean, I can dive into how the spacecraft are doing right now, but I don't know if anyone needs to know that to the level of, you know, real detail. So let me take a look really quickly on Patreon and see if anybody left me any questions here. I'd like to be able to get to those. Everybody, I did my best to try to get everybody to join the chat today. So, Julian, okay, let's see. Actually, let me get Mike first. Mike, you say that NASA prediction model that you're showing here is not the same as the one that's posted on their site. It's showing a mist to the east. A mist to the east. How interesting. I will look to see what if they've redone that. I had looked, actually. I was at Donkey. And from the 28th to the 30th, they only have one result that they've modeled, at least as of earlier today. They have only one CME that they've modeled that is Earth-directed, and that's this one. Let me see if they've updated it. This was from oh, wait. Huh. Oh, model completion time, my fault. Okay. Yeah, the CME impact, the CME inputs was from the 28th at 2200, yeah. So this is the filament eruption, and we will look at it. I think this is the link I can use to open it. Yeah, and I've been here. No, this is the same one. So I don't know what one you were looking at, Mike. This one is, they may have supplanted it. I don't know. Maybe you saw an early run that they revoked. That stuff happens. It happens at NOAA too. If you're fast, they'll put something out and go, "Ooh, oh, let me take that back." Shh, nobody saw that, right? That happens from time to time. You know, because remember, there's a scientist in the loop. We're all working. All of us are working. You know, as diligently as we can, but we're just people, and so sometimes we kind of have second thoughts about, whoops, maybe that model didn't work very well, or it didn't make the consensus. So I don't know. It'd be nice to see what that model is. Okay, Julian asked, as a comparison to NOAA and NASA, check Euphoria. Yeah, you know, I keep forgetting to do that. Thank you for giving me the link. I'm not on the right computer to be able to pull that up right now, but I will. And there's an Australian version, I think, of Enlil as well. My biggest thing and I'll get back in screen, sorry. My biggest thing with Euphoria is that, as of yet, I still see their densities go really high, right? And they're willing, and the people who model, the scientists who model, and I know some of them, and they're fantastic colleagues. But when they model, they'll model 5 or 6 different eruptions all in the same packet. And these models, I just don't know if they're robust enough to handle, you know, a barrage of big eruptions all at once. I think sometimes they have a tendency, because they're you know, hydrodynamic, right? So the storms will merge and then up the density. And you can't have like these merged, you know, regions, these interaction regions. You can't have them merging like that in you know, in these models too often, because it really breaks with reality. We do make a lot of assumptions with a lot of these models because the fact that they can't run faster than real time if we add too many complexities in there. So we dumb them down just so they can run faster than real time, and when they do, sadly, that means they get the physics wrong. And so the magnetic field is not taken into account nearly like it should, which kind of has a tendency to, as you know, when you take fridge magnets and try to push them together, if they're not aligned the right way, they kind of bump off each other and they force themselves away from each other, like bumper cars. And we don't have that effect in these faster than real-time models. We do, these effects are included in the next generation of these models, but those haven't been transitioned into operations yet. So we're still using these others. So those are some of the caveats I have with using Euphoria, but I do watch it, and I have looked at it many times. Someone showed me an Australian version of Enlil the other day, and I've got to find out where that is located, because I have not seen that. It'd be neat to see, to have that in the mix. Now Mosswalk used to run a version of Enlil, but I don't see it anymore. I haven't checked in a little while, but that was always a fun one to be able to kind of compare together and get lots of scientists looking at it from slightly different perspectives and getting a really nice bracketing of model runs depending upon what their particular agency takes into account, right? Because I think we've talked about it before, like for instance, NOAA cannot have, they cannot tolerate false positives. They just can't tolerate it. Their stakeholders really, it costs a lot of money if there is a storm that is forecasted to hit, and these guys go into all their mitigating procedures and set everything into place, and then the storm doesn't hit, and they're like, that just costs us, millions of dollars. What the hell? We can't, and hours and hours of time. We can't do this. So NOAA is very risk averse when it comes to having false positives. NASA's the other way around, right? Because they're preparing for Artemis. And so the Moon to Mars mission, the M2M office, right, they want to know everything. They want to forecast everything. They have a spreadsheet that's like a mile long, and a lot of their people, Corinna, for instance, Alden, she's talked to me quite a bit about this, and they just have to document everything. And I think it's fantastic, but remember, their stakeholders are human missions, right? So when you're trying to protect human life and those types of assets, you don't care if you get a false positive. You want to know. So they're on the opposite end of the spectrum, where they allow a surgeon to make the ultimate decision, but at least the space weather is in play in the trade space. So just those two perspectives on the same event really make for a really nice kind of enveloping of the possibilities. And that's one of the reasons why I love showing NASA and NOAA together, even when they don't agree, because it just gives us a much more synoptic view, a much more well-rounded view of these solar storms and how the forecasters look at them. And I think that's just really critical in the infancy in which we find ourselves in space weather. And so I just really applaud all of their diligence, both at NASA and NOAA. NOAA for being restrained and not putting out those false positives, and NASA for being just eagle eyes on every little whistle and fart that the sun puts out and documenting it tirelessly. Those two approaches are just so needed at a time like this. So anyway, that's how that goes. But I'd love to get more in like Euphoria and those others. Okay, Noise says, if you had to guess how long will solar winds be gusting, you reported that fast solar winds are here for today. Or will it be consistent through August 1st? Those wide swings of the magnetic field in the solar wind are tough. Oh, yeah, okay. Oh, thanks, Noy. Boy, yeah, you put that into some interesting perspective, because oftentimes with these fast solar wind, when you go from one region to another, you begin to go into like you cross a sector structure, and we did do a sector boundary crossing recently, and I know this isn't exactly fast solar wind stuff, but a lot of times those big neutral lines are in there, or you're borderline. They're on one edge of a coronal hole, and so it makes me think a little bit more about paying attention to sector structure, because they are typically very coronal mass ejection like. They're very solar storm like in their rotations. In terms of this particular one, I think right now, and I'll just go to the solar wind. Hold on. Give me a moment. Let me give you 3 days. So sorry this is white. I don't have this computer set up for some reason with my black screen. Typically I have it showing black, but I'm not going to take the time to make it do so. Yeah, we haven't crossed a sector right now. We're sitting at pretty sustained south field though. Right now we are sitting at about 500 kilometers a second, just slightly under it. I do believe that the storm that's going to hit will probably be around the same. So I don't think the solar wind is going to die down all that much, maybe a little bit, but not that much by the time the solar storm reaches us. It'll die down as we go through that solar storm. So it's going to continue to be fast solar wind, and we will likely get some more planar structures. So you'll have to deal with some high variance, high cadence, like very frequently flipping magnetic field back and forth a little bit when this storm, right before or right when this storm is hitting. I don't see, whoop, that's right, that's purple. Let me go to 7 days maybe. Maybe it'll show me. I'm trying to see when we had maybe crossed a boundary, a sector boundary. Oh, there it is. Yeah. I'd have to look at, Noi, this might be a question I have to answer offline. So we crossed a sector boundary here. You can see the purple line going from positive to negative. So that's the sector boundary crossing most likely. And we also got hit because there's a CME in there. Yeah, probably. We oftentimes have a lot of sector boundary crossings in CMEs. This is not a sector boundary crossing. This is just a fold in the sheet, in the current sheet. I don't know. We may be due for a sector boundary crossing. So you may have to get another flip in there. I don't know if that's going to happen inside that storm, but it very well could. So just be aware. And I will answer that more in depth when I get back on Patreon. Okay, I'll look into that more for you, Noi. But hopefully this gives you a little bit of insight. So get ready because there might be something there. Okay, I think that's the last big question from. Yeah, that's the last question from Patreon. How about you guys out here? Have I answered all your questions? Hopefully. Yes, hi, Smash. I don't know if I should call you Smash. I think that's, I'm just saying hi. Good to see you. Yeah. Oh, hi. Yeah, you're making a comment about the sector boundary structure, right? Okay, is that why Cheyenne Mountain had been active recently? I have no idea. I'm not even sure what you mean by that. High tower. I'm not sure. I'm not sure what do you mean by active? Why they've been active? If I can understand that, I'll help you. Have you noticed that this is your biggest spectator live event? No. How many people are on? I'm sorry. Sadly, I have part of my screen covered because of the way YouTube makes me do it. I can't see the comments unless I have my OBS kind of covering part of the YouTube studio. So I have no idea how many people are watching the stream right now. But welcome. I'm glad you're all here. Hopefully I'm answering questions for you. Mosswalk seems to have gone into hibernation. Yeah, I know. What? Why? Does anybody know? Is anyone on who might have an idea as to why we haven't seen a lot from Mosswalk recently? I know that they've got the European Union has a wonderful space weather suite of data products, and they're trying to ramp up the production of them and get them populated. But it's to me, it's almost overwhelming. It's like, oh my gosh, this is so much work. I just hope that they continue to have the funding to keep all of that up. But I think it's being run mainly by the European Union, so it's a consortium. So if anybody has a chance to do it, they do. But their suite of products is it's staggering and it's wonderful. So hopefully that's going to continue, and they'll continue to ramp up even more. Oh, it was up to 1,200 viewers. Wow. Oh, wonderful. Thank you. Great. I hope everybody enjoyed it. Okay. Yeah, Cheyenne Mountain. I'm not gonna get into anything about military ops. I mean, I'm not even plugged into that system, so we can. it's a totally different topic, guys. This channel is far more about space weather, the phenomena, the mainstream. We can talk about fringe science, but you know, it's still very much in the mainstream vernacular. And yes, if you are from Suspicious Observers, welcome, welcome. We are very, you'll find our community is very encouraging and open, but we're here to learn. All of us are, including me. So, do you think this week is going to be epic? What's epic? Give me your definition of epic. I don't know. Is it going to be a nice storm? Yeah. Will it be fun? Yeah. Will it be, you know, again, I won't be able to tell, and none of us will be able to tell until the storm actually hits our upstream monitors, and then we'll be able to tell whether or not it's going to have, you know, decent punch, whether or not the storm is going to be sustained, and then we'll just follow it. Likely we're going to get into the core, right, what we call the core of the ICME, the solar storm, and when we get to that core, we'll likely be able to predict what it looks like, because they are solar slinkies. And so when we watch the magnetic field rotations, we can predict, when we recognize what orientation it is, we can predict what the whole thing is going to look like. So that's the nice thing about getting into these big filaments and hitting close enough to the center. Likely we're going to see that solar storm core, and then likely we're going to be able to predict whether or not there's going to be a lot of southward field. That's when it gets fun. But prior to that, we can't really say. You know, we can just say that, yeah, it's going to be in this range. And is it going to be epic? No. Is it going to be a G4? Not even close. I'm hoping for a G1, okay? I'm got like fingers and toes and all things crossed so that we get a G1, because aurora photographers have been really stymied as of late. We've just gotten these nothing burgers that keep hitting and then giving us, you know, giving us, you know, junk. I mean, yeah, oh, yay, for, you know, a few hours we get something and then it's gone. And we've just been getting that over and over and over again. Here, just, you know, just a tiny bit, right? And it's just nuts. So we're overdue for a decent storm, especially since we started the year with two really good ones. This one isn't going to be anything close to that. Okay, so don't expect it to be like what we saw in February and March. Nah, not going to be that. Okay. Oh, thank you. I appreciate that. Space weather needs to be in universities. Yes, that's why I teach in Millersville. Definitely trying to help create this field of space weather broadcasting and get terrestrial meteorologists to have space weather chops, so you can see it on the 6 o'clock news, you know, during the weather segment, and you don't have to come to YouTube anymore for this stuff. How does Earth's weakening magnetosphere affect storm penetration? Well, it's a mixed bag, right? It causes radiation storms to penetrate a little bit more deeply in. It causes particle precipitation, any kind of particle precipitation, to penetrate a little bit more deeply in. That's not great for aviation, right? Because lower altitudes get higher radiation doses. So not great for aviation, not great for low Earth orbiting spacecraft, because now you get once again, the geomagnetic cutoff, or the rigidity is not, you have lower rigidity particles that can penetrate, right? Lower energy particles that can penetrate further. So not great for spacecraft, not great for aviation, not great for the ISS and astronauts and all of that. But beautiful for equatorial aurora. We're going to start seeing, you know, we already are starting to see a bit of aurora during storms in the equatorial regions. So when you get close to the South Atlantic anomaly, they're seeing aurora in Brazil and in Chile, even south of Hawaii. So those things are neat. That's what's fun. And also GICs, the geomagnetically induced currents, what you get during geomagnetic storms that bother the power grids, that everybody's worried about is going to shut down the power grids, those are going to weaken. So, and that of course is a helpful thing. So everybody who talks about the magnetosphere doing what it's doing and getting weak, remember, it's only one component of the Earth's magnetic system. It's only the dipole component. We have the quadrupole, the octopole, and the other poles, you know, higher order terms that are still there. They're not flipping. So it's not that the magnetosphere is going to go away. So just understand that. Number two, as it does reconfigure, there's bad stuff and there's good stuff, right? And it's not just doom and gloom. So please don't believe all the hype on YouTube. It's just crazy that people believe that we're all going to die. It's just silly, silly. Okay. Sophie asked why filaments aren't numbered like sunspots. Because filament channels refill over and over again. Filament channels erupt and collapse. I mean, they're very, think of them as kind of like rivers. And you have canyons that are magnetic field canyons that are created when magnetic field fingers kind of touch the foot points, as we call them, touch the surface of the sun, right, and penetrate through inside. You can imagine that as being like cliff walls. And then you have a bunch of plasma, a bunch of like this gaseous stuff, but it's kind of, you can almost think of it as like a liquid. And it shoots up the magnetic field lines, but then it rolls back down. And so as it rolls back down, it gets caught in the canyons, as just like water does when it rains. It literally creates like these rivers of stuff. And so in this case, these rivers can be kind of fluid and moving around because the magnetic field changes. So imagine like the Grand Canyon, but the Grand Canyon is kind of shifting around. Its walls are not rock. They're shifting and moving around a little bit. And so these things change and divert. So it's kind of hard to, as well as erupt and disappear and move. And it's just much more fluid situation than an actual sunspot. So it's a lot harder to label. Although if you look at diagrams, we do label them, we just don't give them numbers. We give, there we go. So here's Terry. I love Terry. Terry Spencer is such a great guy. I've actually met him and chatted with him. He's the only one who does synoptic charts at NOAA that are on the computer, and I think they're just so cool. So you can see he did a little bit here. This is the filament, part of the filament that erupted. I think, hang on, where are we? This is a new one. This is a new one since earlier. Yeah, he just updated it. Okay. So you can see some filaments here. This is the craggy stuff that sit along neutral lines typically. So they are labeled, but see, the problem is that filaments can pretty much come up in any of these areas. So they move about, and sometimes like rivers, like water that just kind of moves about. So it's kind of hard to number them because, you know, is this the same as this? If it moves over here, does it stay the same number? Does it change? Sometimes they erupt, then what, you know? The number goes away and you start again, but the filament channel's still there. So it makes it tough to do that. Here's a big filament down here. See? And I bet you part of this prominence that he's got labeled here is part of this filament. It's just the part that's off the disk. So the difference between filaments and prominences is that filaments are on the disk, right? This is the Earth-facing disk. We call it an Earth-facing disk because it's the part of the sun that we can see. And then off the disk is the prominence, but it's still part of this structure. Yeah. Got all sorts of really cool names for things. Confusing as heck, but you know, they are what they are. So hopefully that answered that question. Okay. Okay. I'm looking at lots of conversation. This is great. I'm glad you guys are chatting. Okay, guys, it looks like, yeah, this kid, oh, this is sweet. Thank you, sweet Polly. This channel would be excellent for kids in elementary school reaching the 5th or 6th grade, and that's when they really get absorbed and into space weather. Yeah, thank you. I agree, and actually I do know quite a few children that do watch this channel, so they're paying attention, and I appreciate you pointing that out. Yeah, we need to make space weather part of our daily vernacular, you know. Okay, guys. As Marlene, no, I don't think so. Space weather's been pretty mild over the last week or so. There's really not been all that much going on, so I don't think any issues that you're finding with digital, with wires or cables, things like that. There's nothing that in the space weather that has caused that. So breathe easy from that perspective. Hey, Texas Flash, good to see you. Okay, guys, I'm not seeing any more questions. Thanks, Jerry. Yeah, I just got to Marlene's question. I appreciate you putting that up there to highlight it. Yeah, I really do think that these are the digital anomalies that you're seeing are not space weather related. We really just haven't had enough. If it was a week ago, you know, there are some people that have worked pulling cables for a living, and they do see interference. But unless these are in Canada, I just don't think that there's anything that's happening right now that is that dramatic. Yeah, maybe a week or so ago we might have been able to talk about it, but especially if it's been, I mean, more than a week ago, about 10 days or more ago, I think we could have maybe said something, but I'd have to dig into it more deeply because it's typically not that much of an issue. Some geomagnetic storms can have issues. Sometimes radio interference can have issues if we have big radio bursts. but we haven't had any that are super, super high from what I remember. We've had a couple big M-class flares, but they're, you know, short-lived. So if it's been something that's been ongoing since the 17th, I just don't know if that's related. I'd have to see kind of, you know, I'd have to dig into it a little bit more deeply to find out. But my gut reaction, you know, my perfunctory response is no. The space weather just hasn't been all that intense recently. Okay. You're very welcome, Viviana. I appreciate Viviana? I think it's Viviana. Thank you. I appreciate that. I'm glad you learned more. Was there a recent M4.1 CME? Not over the last couple days. We had, get out of the solar wind again. It was, I think it was region 3376 was the last time we had a big M flare, and that was what? The last one was an M, yeah, that M41 happened on the 28th. So, you know, it's been a couple days. So not recent, if you mean recently like today, no, have not. It was a few days ago. So that was the last big one that we had, and then we had another big M flare here. It was slightly shorter lived. This one was a bit longer. Matter of fact, that was part of the flare. Was that part of the flare that, that was the one that actually launched that radiation storm. So that was 76, that was rotating. That flare, by the way, incidentally, that flare was a lot bigger than an M4. It was occulted, so we didn't really see it. So that could, so region 3376 could be an X-flare flare. That might have been an X flare that we just didn't see because it was blocked mainly. But we will be paying attention to that region as it rotates around. It's another one just like region 3363 that we're paying very close attention to, because if it continues to grow, then, you know, it could give us some trouble on the front side again. Okay, guys. Tweet more, Tamitha. Okay, I will, especially as the storm comes in. But it's been extremely difficult trying to keep up with all the forecasting. But I've been doing my best. All right, guys. Yeah, again, I will tweet more, I promise. Yeah, Arky, if you're talking about this being an X-flare, yeah, on the sun's far side, not Earth side. But yes, this was region 3376, and yes, it could likely have been an X-flare. It definitely was more energetic, and it had this massive storm, as we talked about. Do I do Schumann resonance reports? No, because that's mainly terrestrial weather, right? That's much lower. It's in the neutral atmosphere. So I don't do Schumann resonance. I know some people have asked me to. The reason why, I mean, I could read Schumann resonance, but the reason why I don't mainly is because I am not a terrestrial meteorologist, and so the neutral atmosphere is not something that I do a lot of work with. I need to get skilled in that arena. But you know, you can only get a PhD. It's hard to be very broad when it comes to things, and a lot of times to understand things well, you really should get, you know, a lot more skilled, and that takes time. So I'll get there. Okay, guys. Let's see. I'll see. You're welcome. You're welcome, Polly. And then Mike, you say, I'm new here, Dr. Tamitha, learning a lot, but I have a lot to learn. Love your teaching style. Oh, great. Hopefully, yeah, hopefully I try to get things in a vernacular that is easy to understand. This stuff can be intuitive as long as it's being taught, you know, in a way that resonates with you. I do not dumb down the material, as you can tell. I talk to you all. I don't talk down to you at all. I just try to erase a lot of the science vernacular, because a lot of times that can be, it just gets in the way, and it prevents you from learning, because you get tripped up on all the jargon instead of actually understanding what the phenomena is. And it's important to understand the phenomena. You don't need to understand the jargon. It's not important. Okay. Okay, Secret Al has a question. Dr. Scove, does the increase in pseudoscience in chat have any connection to suspicious I can't answer that. You guys answer that. I'm not even watching the chat. I'm looking for questions. Thank you for baiting me, though. Very cute. It is possible. It is, I don't know, maybe just other people, right? Because we had one of the forecasts recently went sky high, and so there's a lot of new people here today, and I'm appreciative about it. Oh, Jerry, I missed something. I think you had posted something and I missed it. Let's see. One of them, you said shutting down grids will cause my. Oh, you're answering. Okay, good. Yes, thank you, Jerry. A lot of questions that you guys post, especially if you're new, please take a look at my YouTube mini courses. They're all, open, and you can see them. And I even have if you look at my website, I even have a small video that tells you how to take the courses in what order, that kind of thing. If you're looking for particular, if you want to learn all about coronal mass ejections, or you want to learn all about radiation storms, for example, there are different course series, like the CME courses or the C series, the radiation courses, or the P, I think it's the P series. And you take them in a particular order because they build on each other. And they're all there for you, and a lot of the questions that you ask are answered in those, okay? So feel free, please. They're there for you for exactly that reason. Okay, guys, and don't be worried. This is not, this storm is an easy storm. This is a fun storm. Enjoy space weather. Most of the time, space weather is just like terrestrial weather. It's a minor inconvenience, right? Not every rainstorm is a hurricane. Not every space weather storm is some, Carrington event, okay? We're not dealing with Superstorm Sandys 99.9% of the time, so don't worry about it. Enjoy space weather. If you get a chance to get out and see aurora, do so. If you get a chance to help report and show us what you see, wonderful. If you get a chance to get some decent DXing, excellent. And, otherwise, take a look at the webcams, or, take a look at all the activity that we're going to see on Twitter with these storms. It's meant to be fun, not scary, okay? All right, guys, I think that's about it. Yeah, I think I've got it. Okay, guys. All right. It's been wonderful. You guys kept me on for quite a long time. Hopefully you enjoyed the deep dive, and get out there and have some fun. Okay? Talk soon.